Okay, this lesson is going to be on angles, and we are going to sketch angles and work on converting from degrees to radians and radians to degrees. The first thing you need to know is that when we will be talking about angles, we will be putting them on something called the unit circle. So we need a standard position to be in, and imagine that this is 0, 0, this is your origin. This side is going to be called the initial side, and that is always going to be on the positive x-axis. So if you were on a x and y axis, this is on the positive x-axis. We think of this other side called the terminal side as moving, and that's the side we move because this initial side is going to stay put. And so we move in this direction most of the time, and we draw an arrow, tend to draw an arrow to show how we got there. But this is called the terminal side, and that can be in any of the quadrants, and so it's the one that's kind of slanted when you have something that is slanted. So keep the initial side where it is. Think about the terminal side being the one that moves. Okay, now I'm going to talk about a couple of things that we need as we travel and make these angles. As I said, the initial side's always on the positive x-axis, so we're going to start out with degrees because most of you are familiar with that. We're going to call that 0 degrees because if everything's pointing that way, we're going to consider that it has not moved. We are going to go around the circle in this direction, so this would be the positive direction, counterclockwise. And when you've gone from this to this, from this x-axis to this y-axis point, you have gone 90 degrees. And so that's 90 degrees in the positive direction. If you go 90 more, you've gone 180. If you go 90 more, you've gone 270. And if you've made a full trip around the circle, you have gone 360 degrees. Okay, so that's the positive direction again, counterclockwise, and you got to get used to that. You've done that before when you did rotations with geometry figures, but we're using it here with our angles. Now, if you go the other way, if you go clockwise, this would be the negative direction. And so this would still be 0. Your starting point would still be 0. But as you go backwards, clockwise, this becomes negative 90 degrees. As you continue on, you have negative 180 degrees and negative 270. And then if you go around the circle, again, clockwise, this could be negative 360 degrees. So that's how it works. Everything is backwards when you travel clockwise. Now, we are going to be working also in radians, and you should have learned something about those in your previous math class. We travel around the circle not only in degrees in this class, but we also travel in radians. And so everything still starts on the positive x-axis if I'm in radians with 0. Notice there's not a degree symbol because this is not degrees. These will not have a symbol after them. Sometimes they'll put RAD for radians, but a lot of times when we're working with them, we don't put any kind of units. It's just understood to be radians. If you travel in the positive direction, as we were just doing, you end up where we normally would have 90 degrees. That in radians is pi over 2. As you travel on, you come to where we would have 180, which is pi. Keep going, 270 would be the same as 3 pi over 2. And then a full circle is 2 pi. Now look for a minute. This bothers some people because you've been taught since elementary school that a circle is 1, and then if you cut it in half, it's half. And these fractions bother people because the top half of this traveling angle circle is 1 pi, and a full circle is 2 pi. So you're going to have to start thinking about the 2 quadrants on top adding up to 1, and the 2 quadrants on the bottom adding up to 1, so that when you travel all of it, you add up to 2. That's the hardest thing to kind of wrap your brain around. So if I said 3 pi over 4, that's 3/4. That's less than 1. That would be right in here. And that's one of our things that we're going to be working on today is locating angles. Backwards works the same way as with degrees. So if you're traveling in the negative direction, the first thing you come to would be negative pi over 2. The next would be negative pi. Up here would be negative 3 pi over 2, and a full circle would be negative 2 pi in the negative direction. So again, this is the positive direction, this is the negative direction. Okay, and just a reminder, if you've forgotten your quadrants, they follow the direction that we're going to be going, which is counterclockwise most of the time. This is the first quadrant, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So that's just for those of you who have not thought about that in a while. Now, for some examples, I'm going to start out with degrees because most of you feel more comfortable with degrees, but we are going to move to radians. We're going to practice sketching angles. So 240 degrees, I'm just going to draw a little x and y axis. It doesn't have to be perfect. And I'm going to draw the initial side of my angle because it's always going to be in the same place. So 240, if you think about what we just labeled in degrees, that would be past 180, but not yet to 270. So you want to make sure you're in the third quadrant. You also want to draw the little arrow I was talking about to show which way you got to that line. So draw both parts of the angle, the initial and terminal sides, and the little directional arrow. All right, 110 degrees. If you think about where that falls, again, I want to start with my initial side on the positive x-axis, and then think about where that terminal side is going to be. If I'm traveling this direction, as I'm supposed to, since this angle is positive, the first thing I come to is 90, but if I make it all the way over here, I'm at 180. So 110 would be between the 90 and the 180. So as long as you're in that quadrant, I know that you are thinking correctly. So I draw the terminal side and the directional angle. Okay, now I'll do a couple of negative angles. So negative 90, we're going to go clockwise. We still put our initial side on the positive x-axis, but negative 90 would actually land perfectly here, and I would draw my directional arrow. Negative 200. Again, always start with that initial side on the positive x-axis. If I go backwards to that first line, as we just did, it's negative 90. To the second line, it's negative 180. And so negative 200 would be a little past that, about right here. And again, I want to show that directional arrow to show that I went in the negative direction as I was requested to. Okay, now we're going to work with something bigger than 360. We labeled our circle to 360 because that's one trip around a circle. But you may have heard snowboarders, skateboarders, anybody that does turns say, call it a 720. Well, what they're doing is really 2 rotations. And so this is where that directional arrow is very important. You still have your initial side on the positive x-axis. So you have to think, I'm accumulating those angles as I go around. So I'm going to use the directional arrow. If I go around one time, I have hit 360, but 2 times is what would put me at 720. And so that directional arrow is, again, what shows, and it disappeared, what shows that I went around more than once, and I understand the concept of 720. Okay, number 6, negative 400 will be a good one for you to pause and see if you know how to do, because obviously we're going to move into radians after that. Okay, negative 400, again, I always start on that initial side, positive x-axis. Negative 400 would be a little more than one time around, but I have to go in the negative direction. So if I go around one time clockwise, that's a negative 360, but negative 400 will be a little past that. And so I need to draw that arrow and my terminal side in. So I'm one time around and a little bit, so I'm in the fourth quadrant. And that's really what I'm going to be checking, is to make sure you land in that right quadrant. Okay, now let's go to radians, and you have to remember what I said about adding up to 1 and 2. So 2 pi over 3, okay, if we are adding up to 1 to get to here, 2 pi over 3, 2/3 is less than that, less than 1. And so think about, imagine the top being cut into 3 parts. The 2/3 part would land about right here. Even if you can't understand that, you should understand that 2/3 is bigger than 1/2, and so pi over 2, half of a pi is right here, and so it should be past that, but it's not yet 1. So it puts us in the second quadrant, and that's one of those reasonings. You're going to get really good at reasoning through fractions in this course. All right, pi over 6. That is a very small amount. It's actually less than 1/2, because think about it, 1/6 of a pi is a lot less than 1/2 of a pi. So I'm going to start with that initial side. And I apologize for the screen jumping. I'm not sure why it does that sometimes. But since it's very small and you know it's less than 1/2, you're definitely in the first quadrant. So I'm going to draw it about right here, but I'm still going to draw that directional arrow in to show which way I went, because it was a positive pi over 6. Moving on, 7 pi over 2, again, start with that initial side. This time I kind of think about this, because it's a pi over 2, I almost count each quadrant, because one quadrant was a pi over 2. So I think of that as 1 over 2, and I want to get to 7 over 2. So this would be 1 over 2. This would be 2 over 2. This, which is 1. This would be 3 over 2. One time around is 4 over 2, which again is 2. If I keep going, I'm back to 5 over 2. Go some more, 6 over 2. And then a little more, I'm at 7 over 2. So I'm making those marks, but I'm traveling. I need to draw my arrow that path that I went. Sometimes you can do that with those denominators, especially with those pi over 2s, because each one just counts as a quadrant, and it'll get you to this place. So I need to draw my terminal side to finish that out. Okay, let's do some negative ones. Negative pi over 4, again, starting with that initial side, negative going in the clockwise direction, and pi over 4. So if I think in the clockwise direction and I make it down here, this would be negative pi over 2, or like negative 1/2. 1/4 is less than that, so I'm going to be in this fourth quadrant and draw my directional arrow. Okay, negative 5 pi over 6. And the immediate thing that I think is, besides going in the negative direction, 5 over 6 is really close to 6 over 6, which is 1. And so I should be really close to this line over here where I have 1 pi. So my initial side, and then I know that I go and I get close to, but not completely to, 1. So negative direction, I went clockwise, and 5, 6 is really close to 6, 6, which is 1. Okay, 10/3. Now we did, I believe, 2/3 back in example 7, and I asked you to think about, 2/3 being less than 1/2. 10/3, that's a little more in depth. It's kind of like that 7 pi over 2 example, because 10/3 is way more than 2. 2 would be 6/3, and so I know I'm going around more than once. I've got to have a way to count this. So this is how I think about it. Obviously I have my initial side here, and I'm going to count over here, because look at the top. Just ignore the bottom for a minute, even put your hand over the screen. If I was dividing the top into thirds, this would be a third, this would be a third, and this would be a third. So if I do the same thing on the bottom, this is a third, this is a third, this is a third, I have a total of 6 thirds, which is what one trip around the circle is. So I'm going to count at these dotted lines, and I'm going to count the x-axis lines as I go around. So like I did with that 7 pi over 2 example, I'm going to hit each line and I'm going to write down what I'm thinking there. So this is positive, so I'm going to go in the counterclockwise direction. The first one would be 1 pi over 3. The second one, 2 pi over 3. The third one, 3 pi over 3, which is 1. The next one is 4 pi over 3. Then 5 pi over 3. Then 6 pi over 3, and that's reduces to 2 just like it should, but I have to keep going. So I hit this line again, 7 pi over 3, next line 8 pi over 3, next line 9 pi over 3, and then finally to 10 pi over 3. So this is where I land. That means my terminal side is here, but I need to draw my directional arrow to show that I went around more than once. So my directional arrow needs to show that 10 pi over 3 is more than one time around the circle. Most of the time you're going to be dealing with things with denominators of 2, 3, 4, and 6. But for today, we can deal with things that have some odd denominators. Here, this will be a 7. Instead of trying to think about what it would look like to divide up my top into 7 equal chunks, because that's just still hard to think about, I'm going to think of this is 0 and this is 7 over 7, because that's the same thing as 1. I can also figure out what halfway is, because halfway between 0 and 7 is about 3.5. So I can help count that way, or I've got to at least land in the right quadrant. So if this is 0, this is 3.5 over 7, this is 7 over 7. Down here, it would be 3.5 from the 7, so this will be 10.5. And then again, one full trip would be 14 over 7. So I can look right now and I can tell 12 over 7 is less than 14 over 7. So we're not going to be going around the circle more than once. And once I've figured out where these land, I know that 12 falls between 10.5 and 14. So if I draw my initial side, my terminal side is going to be in the 4th quadrant. And since this is positive, I'm going this direction. So that's another way to kind of break up the thought process to sketch these out. Okay, the last thing we're going to be doing is kind of easy, converting from degrees to radians and radians to degrees. I want you to be able to convert both ways, but I do not want you to live in the world of degrees and convert everything, then sketch it, and then convert back. You need to learn to sketch and think in both radians and degrees. Please do not restrict yourself to just thinking in degrees. Okay, so we're going to convert. Just like I say, multiply by pi over 180 and reduce. So I'm going to say 135 times pi over 180. So I'm going to look at it as 135 pi over 180, and then I'm going to reduce this fraction, and that will reduce to 3/4. So this becomes 3 pi over 4. Same thing with 540. I'm going to take 540, multiply by pi over 180. So that gives me 540 pi over 180, and then I just need to reduce that fraction, and I get 3 pi. It doesn't matter if it's negative. So this negative 270, you just carry a negative along, because remember, negative just means we're going in an opposite direction. The numbers are not going to be affected. So I have negative 270 times pi over 180. Becomes negative 270 pi over 180, reduce, and you get a negative 3 pi over 2. And then the last thing is converting the other way, going from radians to degrees. And it's actually the opposite. You multiply by 180 over pi. So just flip what we did upside down, And then don't forget to put a degree symbol at the end, because since we're working in both, you need to know whether you have a radian or a degree as your final answer. So I'm going to take that 9 pi over 2, I'm going to multiply by 180 over pi. And what should happen is the pi's should cancel, and I have 9 times 180 divided by 2, and that becomes 810, and again that's degrees, so I want to make that mark. Alright, negative pi over 2, multiply by 180 over pi, cancel the pi's, I get negative 180 over 2, which is negative 90, and again it's degrees. Some of you may have that memorized just from the sketching we did. Okay, last two. Pi over 6. I'm going to multiply by 180 over pi. The pi's will cancel. I have 180 over 6, and that is going to reduce to 30 degrees. The last one's a little weird. This is a radian, even though it doesn't have a pi with it. That basically means that the pi is like included. It's already in there. And so you still just multiply by 180 over pi. However, you don't have a pi to cancel with, so you're going to end up with a decimal. Just type it in 2 times 180 over pi, and your calculator will give you a decimal, 114.59, that is degrees. So those are a little weird, but it's not anything different than what we're doing. It's just not quite as pretty of an answer. And that concludes this lesson.